All right, everybody, welcome to the video for lesson number 4 on solving exponential equations using the method of common bases. So the goal here for all of these questions is to try and make it so that the bases are the same. For these questions, they're not as common as some of the other equations we'll eventually start solving for with exponents, but it is something that comes up from time to time on the Regents exam. It's actually a big SAT topic, just moving forward, just so you know that. So kind of some simple algebra required here. We just need to know a little bit of mental math. So looking at the number 27, I should notice that that's the same as me saying 3 cubed. So I'm just replacing 27 with 3 cubed. I'm substituting. Same thing with 9. I'm going to change 9 now to 3 squared, and I'm going to raise that to the exponent x minus 3, which was there. Now that I know the bases are the same, the exponents must also be the same. And in math, whenever we have two things that are the same, we can just set them equal to each other. Notice I'm distributing the 2 to everything there in that exponent. Do some quick algebra, right? We're all good at algebra, so we can do that. Don't know what happened there. So we can do some algebra here and get x equals -6. We could check it by plugging back in, but it works. Let's take a look at the next one. 5 is already as small as it can get, but 125, I can change that. So we're going to leave 5 to the 4x. And I'm going to change 125 to 5 cubed, all to the x minus 1. Bases are the same, therefore the exponents must be the same. And in math, when two things are the same, we set them equal to each other. Subtract 3x, and we get x equals -3. Next one, base of 2 can't be changed, but 1/4 can, right? So 2 is just going to stay, so all that's going to stay there. And then 1/4, I'm going to change to 2 to the -2. Bases are the same, so the exponents are equal to each other. I see x squared, I think instantly I want to be equal to 0, so I could either factor, use the quadratic formula, do something. So I'm going to change this all so that the 2 is moved to the other side. Now that I've done that, I can try and factor. So what multiplies to make 2, but adds to make -3? So that would be -2 and -1. So x minus 2, x minus 1. Giving us two answers, x equals 2 and x equals 1. I could check those by plugging back in, and I'll notice they actually both work. Number 3, right? So to solve using common bases and the properties of exponents. So the first thing I want to do here is I want to simplify this left-hand side. That looks kind of messy. So I want to change 243 to have an exponent or as an exponential value here. So instead of having a base of 243, I want to try and make it have a base of 3. The reason why I want to have it make a base of 3 is because I know that 9 can be changed. So 3 to the, what do I think it is? I don't remember. I think it's 5th. 3 to the 5th power. So I could change that to 3x squared as the exponent, and 3 to the 5x is equal to 3 to the 6th power. How am I changing all of that? Well, 9 is really 3 squared to the 3rd power. I know powers to powers get multiplied. In the denominator, 3 to the 5th power is 243. Powers to powers get multiplied. So now if I use my properties here of exponents, I could subtract these two exponents, giving me 3 to the x squared minus 5x equals 3 to the 6th power. Bases are equal, so the two exponents are equal, so I have this equation. Again, I see quadratic, I want to solve, so I'm going to move the 6 to the other side and solve by doing some factoring. What multiplies to make -6, but adds to make -5. So that would be -6 and +1. No need for the whole AC method here because there's no value in front of x squared. It's a 1. Let's keep going. Number 5 says, consider this equation. What are the values of x? Now, this one's kind of tricky. We didn't do anything like this in class, right? So we have to do a little bit of thinking. I can't make 5 have a base of 1, but I can make 1 have a base of 5. And you might be saying, how? Well, 5 to what power makes 1? Well, wouldn't that be 5 to the 0 power? Because anything to the 0 power makes 1. So I can rewrite this as 5 to the x squared minus 16 equals 5 to the 0 power. Bases are the same, exponents are equal. So I have x squared equals 16, which I can factor by using difference of two squares, x plus 4 and x minus 4, giving me the two answers of x plus or minus 4. That's it. Not too bad. Hopefully this video helped you with your homework assignments. All right, keep up with those weekly review assignments. They're important, not just for your grade, but also just to see, hey, what do I actually know that I can do on the Regents exam? Or, hey, what do I not know that's on the Regents exam that I still need to review or ask me about? All right, good luck with your homework, and I will see you all tomorrow.